Imagine standing in a bustling chemistry lab. The air smells of curiosity and anticipation. You have a mission in your hands to prepare a 500 milliliter solution of hydrochloric acid, and all you have is a 20-gram sample. Daunting? Perhaps. Impossible? Absolutely not. Welcome to the world of chemistry, where numbers and elements dance together in a symphony of science. Our task today is to unravel the mystery of preparing a hydrochloric acid solution. So, grab your lab coat and safety goggles. We're delving into the exhilarating world of molarity, moles, and molecular weight.
Let this adventure begins with our chemistry teacher of all, known as Gonarsh. To start with,
you need to calculate the mass that will be needed to weigh on the chemical balance, and we have done the calculations already. I'm preparing 0.1 molar sodium hydroxide solution, and I'm using 500 centimeter cube volumetric flask. I'm not using 1 dmk, so half of it that I'm using. So the mass is being calculated using concentrated times molar mass and volume, and my mass here is 2.0 grams. So I needed to weigh 2.0 grams of the sodium hydroxide pellet in order to prepare the solution. So that's my chemical balance that I'll be using to prepare the solution. So first of all, I'll put my beaker, that's dry beaker, clean dry beaker, and you put it on the scale like this. So that's the weight for the beaker, 53.38 grams. So that's not the weight of the beaker that I want. So we have here tie. I have to tie here. We have here on and off. We have here tie. The moment when you press the tie, it will set to 0.00 grams. So any weight that you put it in the beaker, will record the mass straight. So that's subtracting the mass of the beaker. Is that okay? So let me tie it. So that's my tie. I will say 00 mass. So anything that I put it inside the beaker is my mass. So I have not subtracted it from the mass of the beaker. So I have tied it. Now, with the help of my spatula, then this is sodium hydroxide pellet. You know, sodium hydroxide, whenever you are using to prepare solution, you need to cover it fast because it is very, very hygroscopic. It is also the liquid sense. It absorbs moisture from the atmosphere. It's one of their passports. Why is it that sodium hydroxide cannot be used to prepare standard solution? Although we used to prepare the solution, that the solution that we used to prepare it is not standard, because when you open, it absorbs moisture from the atmosphere. It is very, very, very hygroscopic. It is also the liquid sense. It absorbs moisture from the atmosphere. So whenever you are weighing, you need to be done very, very fast. Other than that, if you are trying to weigh the 2.0 gram, yes, the atmosphere will be added a weight to it, so that, and therefore wrong mass will be recorded. I just need only what? 2. So are you watching? It's more than, then you fetch some for it. 2.7. I still need to fetch some from it. 1.9. So I need a little amount in order to add. Still not within the 2.0. Have you seen it? So I have weighed my 2.0 gram. Then you remove it. Then you add your distilled water to it. Then you stir it gently like this. So you stir for it to dissolve, all the solutions to dissolve. So whilst stirring, then with the help of a funnel, you transfer the solution into the volumetric flask like this. Then you add more water to it. And make sure all the pellets have been dissolved in the solution. So I was talking about rinsing. You need to rinse everything. and you rinse all the beaker. For some of the pallets can stuck inside, so you rinse everything. Then you top it up with more distilled water. So here you need to take your time very carefully. I'm topping it up. You use this one to top it up. Be careful. So when you add mark what you prepare it again, it means you have destroyed the concentration. So slowly add. It's okay. Then you shake it like this for it to mix together to form a uniform solution. Is that okay? Are you watching? Okay. Mercury will turn upside down like this. Into honey ready. So that's the meniscus. Below eye level. Is that okay? So that's the meniscus. Then when we are done, with the help of the label, then you label it as I prepare sodium hydroxide. So you label it concentration equal to 0.10 molar. I prepare 0.1 molar. And when you are done, then you say you should label the solution that you have. You can even put this one there, sodium hydroxide, because it's very simple, like a soup. Then you place it like this. Now I prepare my 1.0 molar sodium hydroxide. Is that okay? If you want to test the solution, you know that the base, whenever the base comes into contact with phenolphthalein, it must give me, for a base, phenolphthalein will give me pink. Let us see. Yes, that's my base. Is that okay? This one converted phenolphthalein confirms that it is a base. So I have prepared, I have prepared my 1.0 molar sodium hydroxide solution.